Okay, in this video, we're going to try and understand some basics about exponential expressions and exponential functions. And the first thing we're going to do is we're going to look at the difference between a linear expression versus an exponential expression, or a linear function versus an exponential function. Okay. The first thing we're going to say is that an exponential function is the variable is in the exponent. Okay, so here is an exponential function right here. You can see that the x is in the exponent. Okay, it's 3 to the power of x. This one, however, this is linear. Okay, this is a linear expression. And a linear, the variable is not in any exponent at all. And you can see here that this is 3 times x. And the only power here is 3 to the first power and x to the first power. So in a linear, all of the powers, all of the exponents are numbers, not variables. But exponential functions, they have a variable in the exponent. Okay? And let's see another difference here. If we were to plug in some x's, 1 through 4 into each one of these, we're going to get very different numbers. Okay, we know that if we plug a 0 in for x, 3 to the 0 power, we've already said that that equals 1. But 3 times 0 in the linear, well, that equals 0. Okay, now this is interesting. To the first power, 3 to the first power equals 3. 3 times 1 also equals 3. So linear functions and exponential functions, when x is equal to 1, they often equal the exact same thing. Okay, but now it's going to get different again. Now let's plug in 2 for x. 3 to the second power, well, 3 squared is 9. But 3 times 2, that equals 6. Now let's plug 3 in. 3 to the third power, we already said 3 times 3 times 3. So this is 3 times 3 times 3. And 3 times 3 is 9, times another 3 is 27. That's what's happening here is we're basically multiplying each of our answers. The answer is being multiplied by 3. 1 times 3 is 3. 3 times 3 is 9. And 9 times 3 is 27. Well, then for 4, we'd have 27 times 3, but we'll get to that in just a minute. Now we're going to have 3 times 3. If we plug a 3 in right here, 3 times 3 equals 9. Okay, well, this is interesting. We do see a 9 again, but it's not in the same place. Okay? And then lastly, we're going to plug in 4. Well, we said we can get this answer by just doing 27 times 3. And 27 times 3 is 81. But also 3 to the fourth power is 81, because we saw that previously. Here we would do 4, we'd put a 4 in for x, and 3 times 4 is 12, okay? And so you can see that linear and exponential functions behave very, very differently. All right, now let's look at the parts of an exponential expression, okay, or an exponential function, okay? So we saw this earlier. We saw 7 times 1.23. We had to the 8th power, but now we're putting it to the x power. Why are we putting it to the x power? Because it's a function. We're going to have a whole bunch of outputs. If we put in an 8 for x, if we put an 8 here in for x, we'll get what we got before, which was like 36.672. Okay, but if we put a different number in here, if we put a 1 in, we would get just 7 times 1.23. If we put a 0 in, then this 1.23 to the 0 power would equal 1, and we'd multiply it by 7, and we'd just get 7. Okay, so what we have here is this is a component, this is a component, and then this is a component. And then we have a fourth component, which we call r. Okay, and the letters that we're going to use are, for this position here, we're going to use the letter A, and for the base of the exponent, we're going to use the letter B, and then the exponent can be either a t or an x. Okay, so this component right here, this front component, we call that the starting value, and the base of the exponent, we call that the growth factor. Okay, now it can also be called a decay factor. It can be a decay factor if the number if b is less than 1. So let's make a note of that here. If b is greater than 1, we have growth. And if b is less than 1, we have what's called decay. Okay? Growth means that the numbers get larger and larger. Decay means that the numbers get smaller and smaller. So if we put, but that's only if we put a positive number in here. Okay? Interestingly, if we put a negative number in here, it turns this into a number that's less than 1, and it suddenly becomes a decay function. Okay? All right, so this number is called the starting value. This is called the growth factor, and the exponent, of course, is called the exponent. Then we have what's called the growth rate, and that's this r right here. Okay, and r is related to b. If we say, we would say that b is always equal to 1 plus r, and so then if we solve for r, we get the growth rate. Okay, so here, let's say for this function, what is the starting value? Well, in the position of a, we have a 7, so the starting value is 7. What's the growth factor? Well, in the position of b, we have the number 1.23, and the exponent is x. Now, if we want to find the growth rate, r, what we have to do is we have to set up this equation, b is equal to 1 plus r. Well, b is 1.23, the growth factor. So if we put the growth factor here, is equal to 1 plus r, we can just do some simple algebra. We just have to subtract the 1 here, and that means we have to subtract 1 over here, and 1.23 minus 1 is equal to 0.23. So the growth rate is r is 0.23. Okay, let's do another example like this. All right, here's another example right here. We have f of x is equal to 5 times 0.85, or just 0.85, to the power of t. So the exponent is t. Now notice that the base of the exponent is less than 1, and therefore this is a decay function. So what is the starting value? It's 5. What is the decay factor? We could say growth factor, but I'm saying decay so that we know that it's getting, the numbers are going to get smaller. The growth factor is 0.85, or we can call it the decay factor, which is 0.85. And then if we want to find the growth rate r, here's what we're going to have to do. We're going to have to do some algebra. We're going to set up our b equals 1 plus r. So in this case, b is 0.85 is equal to 1 plus r. Okay, and we're going to subtract 1, and this is going to cancel. And 0.85 minus 1 is negative 0.15. And so that is r. So the growth factor, the growth rate is actually a negative growth rate, and that's what makes it a decay. We have negative growth, so it's negative 0.15.